welcome back to the class. And yesterday, what did we discuss? We discussed about network components. So our first topic was what is a network? What is a network? Connection between two or more nodes. Okay. Connection or communication between two or more nodes. Okay. What is a topology? Topology is a graphical representation of a network. It shows how the network components are connected in a network. Correct. And how many types of topologies are there? There are two types of topologies. One is mesh topology, one is star topology. Okay, in mesh topology, each component in the network is connected to every other component in the network. Correct? Complex network. Star topology, each component in a network is connected to a central device. Okay. Then we saw what is unicasting, multicasting. What is unicasting? One-to-one communication is known as unicasting. What is multicasting? One to few or selected number of members in the group or in the network. Okay. What is broadcasting? One to all. Okay. And what is anycasting? Communication from one host to the nearest host in the network. Correct. Then we saw what is broadcast domain, collision domain. Correct. What is a collision domain? In collision domain, what is half duplex and what is full duplex? What is half duplex? It is like one-way communication. At one single point of time, only one host can communicate. Other host can hear, and after the communication is over, the other host can communicate to the first PC. What is full duplex? Two-way communication. What is the best example for half duplex? Walkie-talkie. Correct. And what is the best example for the full duplex? Normal calls. And then we saw the introduction to OSI. We didn't study the OSI fully. We just saw few brief points of OSI to study about router, switch, and hub. Okay. So yesterday we studied about network layer, data link layer, and physical layer. We just saw the outline of it. So network layer uses IP addresses, and data link layer uses MAC addresses. Physical layer uses cables. Good. What are the types of addresses we discussed yesterday? IP addresses and MAC addresses. In IP address, there is again two types, IPv4 and IPv6. IPv4 is 32-bit. IPv6 is 128-bit. Okay. MAC address is 48-bit. IP address is also known as logical address. Okay. MAC address is also known as physical address. Good. Then hub. What is a hub? We saw this 5 characteristics. Hub is layer 1 device. It's a dumb device. Okay. It has single broadcast domain. It has single collision domain, and it works on half duplex. To overcome hub issues, we introduced switch. Okay. Switch, what are the characteristics? It is a layer 2 device. It is an intelligent device. It has single broadcast domain. It has active port collision domain, and it is full duplex. Good. Router. It is a layer 3 device. Why is it a layer 3 device? Because it works on IP addresses. And why is switch a layer 2 device? Because it works on MAC addresses. Okay. Layer 3 device, it is an intelligent device. Why? Because it has memory, it can store, correct, it can maintain tables, it can maintain routing tables. What are routing tables? We will see when we start routing protocols. And switch, what does it maintain? It maintains a MAC table. Correct? Okay. It is also full duplex. It has per port broadcast domain and active port collision domain. Okay. Then we saw types of cables which we use in packet tracer. We use a straight through cable to connect two different types of devices. We use a crossover cable to connect two similar types of devices. We use a serial cable to connect serial interfaces in routers. Then we use a console cable to configure the new device or any device. Whenever you want to configure from your laptop to a new network device, we use a console cable to configure. Then fiber cable, it is used for transmitting large amounts of data at higher speeds. Okay. Okay, so make a note of this. A router maintains a routing table, and router also maintains a ARP table. Router maintains two types of tables. One is routing table, one is ARP table. ARP table in a router is valid for 4 hours. What? No, ARP, ARP. This one, ARP table. Address resolution protocol. We will see what ARP table is when we discuss about ARP concept. Okay. Just know that these tables are present in a router. In a router, there will be routing table and ARP table. Okay. Refresh time for ARP table in a router is 4 hours. Okay. And there will be a ARP table in PC also. So refresh time for ARP table in a PC is 24 hours. And in switch, there will be MAC table, a table which maintains MAC addresses. Okay. And this table in switch is refresh time is 300 seconds. Did you guys note down those points? This is just an example. So this is how an ARP table will be in a PC. There will be IP address information, MAC address information, type. It says dynamic or static. If it is dynamic, this entry will be refreshed. This entry will be removed after 24 hours because ARP table in a PC is valid for 24 hours. Okay. There will be MAC address information, IP address information, and type will be mentioned as dynamic or static. If it is static, it will not be removed from the table after 24 hours. If it is dynamic, it will be removed from the table after 24 hours. Okay. Then this is MAC table, which is in switch. MAC table is maintained in switch. You have VLAN information. This we'll see later when we start switching concepts. Again, here you have MAC address information, type. It's dynamic or static, and there is port number. So in a switch, there will be ports to connect the devices. Do you see these? These are the ports to connect devices. So each port will have a number that is known as port number. Okay. And MAC addresses can be mentioned in 3 formats. Okay. It all means the same, but just 3 different formats to represent the MAC address. Okay, HP might use this format to represent the MAC address. Cisco might use this format to represent the MAC address, and Dell might use this format to represent the MAC address. But all 3 are same, but different representation for MAC addresses. Okay, make a note of this. And this ARP table will be present in router and in PC. Okay, refresh time for this ARP table in router is 4 hours. Refresh time for this ARP table in PC is 24 hours. MAC table? No, MAC table will be in a switch. Refresh time for MAC table is 300 seconds. So guys, see this entry in the MAC table is static. So will this entry be removed after 300 seconds? No, it will be present. But this entry is dynamic. So after 300 seconds, this entry will be removed. Okay, guys, look at this example. Okay, so in this example, I'm taking 4 PCs. Okay, there are 4 PCs here, and they are connected to one switch. PC1 is connected to switch on F0 by 0 switch port. PC2 is connected to switch on F0 by 2 switch port. Okay, PC3 is connected to switch on F0 by 3 switch port, and PC4 is connected to F0 by 4 switch port. So right now, switch has these entries, correct? Type is dynamic. By default, it will enter the entries as dynamic. If we want to make it static, then we have to manually make it static. Okay, default is dynamic. Port number is F0 by 1. Okay, See this example. Now, if PC1 wants to send some message to PC4, okay, it will generate a message, correct? Okay, see this. Now, if PC1 wants to communicate to PC4, what will it do? It will send this message to switch. What will switch to? Switch will refer to its MAC table. Okay, PC1 would have mentioned destination MAC address as DDDD. So it will refer to its MAC table and it will forward the packet to PC4. Now PC4 wants to communicate to PC1. PC4 will send this message to switch. What will switch to? Switch will refer to its MAC table. It will understand that source MAC address sender is DDDD and receiver should be 4As. So it will forward this packet to PC1. Correct? This is a unicast messaging, one-to-one communication. Correct? Okay. So after 300 seconds, assume this entry is removed. Okay. And PC1 now again generates a message. It informs that sender is PC1, 4As, and receiver is 4Ds, destination. Correct? It will send this packet to switch. But what has happened? 4Ds is missing. Correct? There is no entry after 300 seconds. So in this scenario, what will switch do? It will broadcast this unicast message to all the PCs. Okay? PC3 and PC2 will drop it because this message is for PC4. The same message will be sent to PC2 and also PC3. But these two PCs will drop this message. Okay. PC4 will reply back. Okay. Then there will be an entry again. Okay. Switch. First, when it receives this message, since there is no DDDD entry, a unicast message is flooded to all the PCs. A unicast message is broadcasted. So this scenario is known as unicast flooding. Okay. A unicast message sent by PC1. Okay. Switch broadcasts it because MAC table has been cleared after 300 seconds. Okay. Still, PC1 is sending a unicast message only, no? But that unicast message is broadcasted to all the PCs. Correct? This scenario is known as unicast flooding. And when PC4 gets this packet, PC4 will reply back to switch. So then switch will again make an entry for PC4. Okay. Suppose now, look at this. Now again PC1 sends a unicast message to PC4. Will it be broadcasted? PC1 again it will generate a message. It will send to the switch. What will switch to? Refer to the MAC table. Now it has the entry. It knows where to send. So it will just forward that packet to PC4. There will be no broadcasting again. Okay. Make a note of unicast flooding scenario. Unicast flooding is a scenario where PC sends a unicast message, but since switch has cleared its MAC table after 300 seconds, unicast message will be broadcasted to. Okay. I'll type it. Okay. So yesterday we discussed a little bit about IPv4 address and MAC addresses, correct? So today we will discuss more about IP addresses and subnetting. So again, coming back to the topic, what are the types of addresses present in networking? IP addresses and MAC addresses. IP addresses are also known as logical address. MAC address is also known as physical address. So IP address, there are two types, IPv4 and IPv6. IPv4 is 32-bit. IPv6 is 128-bit. And IPv4, we denote it using dot decimal notation. Okay, we use numbers and then we separate the numbers with a dot. So that's why dot decimal notation. And IPv6, we use hexadecimal format. We use numbers and alphabets. Okay, MAC addresses again hexadecimal format. This is the example. We use numbers and alphabets. Okay, now we will discuss about IPv4 address. Later we will discuss about IPv6 address. Okay, so IPv4 address. An IP address is a unique address that identifies a device on the internet or a local network. Okay, IP stands for Internet Protocol. An IP address is a string of numbers separated by a dot. It is 32-bit in size. So it has 4 octets and each octet is 8 bits. Okay. Each number is a set in a set can range from 0 to 255. Okay. The full IP address range goes from 0.0.0.0 to 255.255.255.255. Total IP addresses possible is 2 to the power 32 in IPv4. So in decimal format, it is notated like 192.168.10.1. But computers work on zeros and ones. So what will they do? They will convert the decimal format to binary format to understand. 192.168.10.1. When you convert it to binary format, it will be represented like this. Okay, IPv4 has 4 octets and each octet is separated by a dot. And in each octet, the range is from 0 to 255. Each octet can vary from 0 to 255. Each octet is 8-bit in size. So there are 4. 8 plus 8 plus 8 plus 8, 32 bits. Okay? Noted down. What are IP addresses, guys? IP addresses are like your house address. Correct? The post. When you send a post, what will the postman look at first? He'll look at the IP address. He will reach to the correct house. And after reaching to the correct house, he will look at the name. Correct? That is MAC address. We use IP address to transmit data packets from one network to another network, from one area to another area. And once it reaches to the correct area, how do we deliver it to the correct person? Using MAC address. So in college, guys, for example, in college, everybody has names, every student has a name, but how are all the students identified? Using register number, correct? So register numbers are like IP addresses. Every student is identified in the class or in the college using roll numbers, correct? We use their roll numbers to identify. Done? Okay, so next let's see conversion. So we humans use decimal numbers to remember the IP address 192.168.10.1. But PC will convert this decimal number to binary format. How does it convert? We'll see that. So let's convert 192 into binary. Okay. How do we convert? So anybody here knows conversions? Binary to decimal, decimal to binary? You know? Anybody else? You know? Okay. So first let's see conversion from decimal to binary. 192. Okay. 192 is the number. Divide 192 by 2. What do you get? 96. It's 96, no? Divide 192 by 2. Yeah. 96. Write 96 here. What is the remainder? 0. Again divided by 2. 96 when you divide by 2. 48. Correct. Remainder is 0. Now divide 48 by 2. 24. Remainder is 0. Okay. When you divide 24 by 2, remainder again is 0. Fine. Divide 12 by 2, remainder is 0. 3, 0. Next, divide 3 by 2. Divide 3 by 2. No, we shouldn't use fractions. So we have to use whole numbers. Yes. This will be 1. Correct? 2 ones are 2. Remainder is 1. Again divide 1 with 2. 2 zeros are 0. Remainder will be 1. Okay. So now we need to look from the bottom to top. What did we get? We need to look at the reminders. What did we get? 1 1 0 0 0 0 0 0. Did we get 8 bits? So 192. When you convert it to binary, you get 1 1 0 0 0 0 0 0. Now suppose if you are converting 10 to binary, okay? 10. Can you divide 10 by 2? 5. Remainder is 0. Next, divide 5 by 2. Correct. Remainder is 1. Divide 2 by 2. 1. Remainder is 0. Okay. Can you divide 1 by 2? 0. 2 zeros are 0. Remainder is 1. Okay. Now in this scenario, we have got only 4 digits, but octet is 8 bits. Correct. But we have only 4 bits. Okay. So it is 1010. This is what we got from. We need to look from bottom to top. Look at the reminders. Okay. So we have got 4 bits, but in an octet there has to be 8 bits. So what do? We fill the initial 4 bit with zeros. 1 2 3 4. Okay. Suppose if you have got 5 digits, so initial 3 digits has to be filled with zeros. So total there has to be 8 bits, 8 numbers. Now can you guys try for this number 168? Try for 168. Just keep dividing the number with 2 and look at the reminders. 01 01. Nope. Check again. It has to be 10 10 1 0 0. Do from bottom to top. Look at the reminders from bottom to top. Online guys, convert 168 to binary and let me know the answer.
Sir, 1010. 1000.
10101.
000.
Yeah, 8 bits.
Yes.
This is the answer, guys. Check if you are getting this. 168 divided by 2. What is the answer?
84.
Okay. 84. Remainder is 0. Again divide this by 2. What do you get?
42.
42. Remainder again is 0. 42 divided by 2.
21.
Okay. Remainder 0.
1. 0, 0.
Okay. 21 divided by 2. 10.
10.
Good. Remainder
1.
1. Okay. 10 again divided by 2.
5 times.
5.
5.
And we get remainder 0. 5 divided by 2. 4. Remainder, sorry, it will be
1.
2.
2 are 4.
1. Now 2 divided by 2. 1. Remainder 0.
0.
1 again divided by 2.
0.
Quotient will be 0. Remainder will be 1.
1.
Check if you have got the answer. See from bottom to top. Look at the reminders from bottom to top. What is it? 1 0 1 0 1 triple 0. Did we get the answer? 1 0 1 0 1 triple 0. Okay. So understood decimal to binary conversion. Okay, you're not able to see it on the screen. Okay, guys, understood? Decimal to binary. Now, if we are given binary, okay, the same number, can you convert to decimal? How do we convert to decimal? Suppose if they give 116 zeros, how do you convert it to decimal? Wait. Next, let's see conversion from binary to decimal. Okay, this is the binary number given. Convert this to decimal. What should we do? We need to multiply each digit with a 2 power 0, 2 power 1 base. Okay. First, let's write the base. There will be 2 power 7, 2 power 6, 2 power 5. Okay, guys. So what we have to do is spread the number. Okay. First number is 1, 1, 0, 0, 0. Okay. This is the base. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay. So what is the answer for 2 power 7? 128. Okay. Next, 2 power 6, 64. 2 power 5, 32. 2 power 4, 16. 2 power 3, 8. 2 power 2, 4. 2 power 1, 2. 2 power 0, 1. Anything to the power 0 is 1. So these values we need to multiply with these digits. Okay, this is the base. Okay, so 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 to the power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. Now multiply 128 with, multiply this row with this row. 128 into 1, what is the answer? 128. You need to add the digits. Plus 64 into 1, 64. Plus 32 into 0, 0. Plus 60 into 0, 0. 8 into 0, 0. 4 into 0, 0. 2 into 0, 0. 1 into 0, 0. Now, if you add all these numbers, what is the number you get? 128 plus 64?
192.
192. Okay. You need to multiply the binary number with the base value. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Multiply. When you convert 2 power 7, it will be 128. Value for 2 power 7, 2 power 6 in all these numbers is 128, 64, 32, 16, 8, 4, 2, 1. Then multiply this with the binary number, whichever they have given. After multiplication, add them. You will get 192. Now, can you try for 168? 1010, 1000. Online guys, did you convert 1010 1000 into decimal?
Yes, sir.
So now what do? Same base values. We spread the binary numbers to the base values. Okay. Let's calculate the answer. 128 into 1. 128.
128.
64 into 0. 0 plus 32 into 1.
32.
32 plus 16 into 0. 0. 8 into 1.
8.
Okay. Then 4 into 0. 0.
0.
Plus 2 into 0. 0. 1 into 0. 0.
0.
Add all these numbers. What do you get? Check. 128 plus 32 plus 8.
168.
168. We got the answer. Okay. Do you want to convert 10? Do you want to convert 1010 into decimal? You will get 10. Okay. Did you guys understand conversion? Decimal to binary, binary to decimal. If you are converting from decimal to binary, we keep dividing the decimal number by 2. And then we make a note of the reminders from bottom to top. Okay. Suppose if we get 4 digits or 5 digits, we take down that number and initial bits should be filled with zeros. So total 8 bits has to be there. Next, binary to decimal. What do? We take the binary number, spread across the base. Okay. And then multiply the value with binary number. After multiplication, add those values. You will get the binary number. Sorry, decimal number. Okay. After you add, you will get the decimal number. Okay. Decimal to binary, binary to decimal. Understood? Cool. Okay. So IPv4 address. We know that it ranges from 0.0.0.0 to 255.255.255. Correct? Now those many address has to be managed. Okay. We have a huge range 0.0.0 to 255.255.255. So to manage it, we have divided IPv4 addresses into 5 classes. Class A, Class B, Class C, and Class D. Sorry, Class A, Class B, Class C, Class D, and Class E. Okay. So Class A ranges from 1.0.0.0 to 126.255.255.255. Okay. Class B ranges from 128.0.0.0 to 191.255.255.255. Class C ranges from 192.0.0.0 to 223.255.255.255. Class D ranges from 224.0.0.0 to 239.255.255.255. Class E ranges from 240.0.0.02, 255.255.255.255. Make a note of this. I'll tell you. Even 0.0.0 is missing, no? Done? Okay. So the next slide says, we do not use 0.0.0.0. Do we use roll number 0 to any student in the college? No. Right? Similarly, we do not use 0.0.0.0. And 127.0.0.0 is usually referred to as loopback address. So usually we do not use it for assignment purpose. We use it for loopback IP addresses. What are loopback IP addresses? We will discuss when we start routing protocols. Okay. Class A, B, C are used for assignment purpose. Generally, to assign IP address to devices in the network, we use class A, class B, class C IP address range. Class D is used for multicast group. What are this multicast group? Again, we will get to know when we start routing protocols. Class E is reserved for research purpose. Class E is usually used for research purpose. And we use class A, B, C for assignment of IP addresses to devices in the network. Is any new members today? Anybody joined today? You joined today? Okay. What is your name? Shiva Pratap. So you will attend offline classes? Okay. Okay, guys. Today, ping me on my WhatsApp number. We'll create a WhatsApp group. Okay. After the class, ping me, and we'll create a WhatsApp group. And then after I create the drive link, I will post it in the group. Okay. Okay, guys. So coming to the next slide. First octet range. How do we identify if an IP address is class A or class B or class C or class D or class E? We look at the first octet. This octet is the first octet. Okay, we look at the first octet. If the first octet ranges from 1 to 126, correct? Look at this. Class A IP address ranges from 1 to 126. Okay, if the first octet ranges from 1 to 126, then it is class A. If the first octet ranges from 128 to 191, class B. 128, 191. Now class C. If the first octet ranges from 192 to 223, then it is class C. 192 to 223. Sorry, 192 to 223. And these are the binary format of these numbers. 1, when you convert it to binary, it is 7 zeros and 1. 126, when you convert it to binary, it is 0, 6, 1s. Okay. 128, when you convert it to binary. Sorry. So 1 to 126, 1 when you convert it to binary, this will be the value. 126 when you convert it to binary, this will be the value. 128 when you convert it to binary, it is this. 191 when you convert it to binary, it will be this. 192 to 223, it is class C. 192 converted to binary, it will be 110 and rest all zeros. 223 converted to binary, this is the value. In the first octet, if it is 224 to 239, class D IP address. If it ranges from 240 to 255, class E IP address. And what is common? Convert these numbers to binary. Okay. And you can look at the sequence. All the class A IP address, when you convert it to binary, first bit will always be 0. Class A IP address, first octet ranges from 1 to 126. So when you convert 1 to binary and 126 to binary, look at the sequence. First bit is always 0. Okay. Class B 128 to 191. In this, first two bits are same. Okay. Class C 192 to 223. First three bits are same. 224 to 239. First four bits are same. Class E 242 255. Again, first four bits are same. Make a note of this.
So,
Yeah.
what do you mean by loopback?
Loopback IP address we will discuss when we start routing protocols. Right now, just know that 127.0.0.0 is a loopback address.
Okay.
Okay, guys. So tell me which class IP address is this? How do you identify which class IP address is it? We look at the first octet and decide. What is the first octet? 10. Look at the slide. Class A ranges from 1 to 126. Look at the first octet. So looking at the first octet, what can we say? It is class A. Next, class A. Again, class A. Online guys, which class is it?
Class B.
Class B, sir.
Look at the range. Tell me under which class does it fall?
Class B, sir.
Okay. This
Class C, sir.
class?
C.
Okay. Class C. This
Class C.
class C?
Yes,
Sure?
Yes,
sir.
sir.
Yes.
Yes, sir.
Class C? Okay. This class D?
Class E.
Class D, sir.
Sure?
Class E, sir.
Check the table.
Class E.
Class E.
Class
E.
E? Okay. This
Class E, sir.
class?
E. One class here.
Sorry?
Like 255 is okay, so class C.
Look at the range. Class A ranges from 240 to 255.
Yeah.
Okay, this. Check the IP address.
Class D, sir.
Is it a valid IP address? Has to range
288.
from
No, sir. No, sir.
0 to 255. So is it a valid one?
This is not valid, sir.
Let's see. Now,
Class
Class D.
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 is it valid? Sure. Okay, it's valid. Class A, B, C, D, E, D. Check the range 224 to 239. First octet 225. Class D. Which class? Invalid. We do not use this IP address anywhere. Okay. So you guys know how to identify which class IP address it is now? Which class? Easy, that's why. Okay. Now, Check. 110. Look at this table. This is
Class C.
class C. Class? Okay.
Class A, sir.
Okay. Which class? Check the range. Class A? B. Class B. Which class?
E, sir.
Okay. Class E. Which class?
D, sir.
Class D?
Yeah.
Okay. So you guys understood looking at the binary format? How do we recognize which class? Look at the common bits. It starts from 0, then it is class A. Which starts from 10, class B. Which starts from 110, class C. Which starts from 1110, class D. It starts from 1111, it is class E. Okay. So next, we'll see what subnetting is and then we will end the class. Okay. What is subnetting? Anybody knows what is subnetting?
In 27, it is divided into like 56. We can divide now the classes.
Okay. Okay. Any other definition? Okay. Allocation of IP address. Okay. Anything else? Any other definition? What is subnetting? Just the definition. We will see what is definition and then we will end the class. What is subnetting? So class A, B, C, we have a huge range of IP addresses, correct? We need to economically assign those IP addresses to the devices. Why? Because IP addresses we have to purchase from ISP. So if we are purchasing IP addresses from the ISP, we need to properly use it. We need to minimize the wastage of IP addresses. So to minimize the wastage of IP addresses, we have introduced subnetting. What is subnetting? Subnetting means dividing a network to economically assign the IP addresses to the devices. Now class A, B, C, we have such a huge range of IP address, but we have only 10 devices in the network, correct? So how do we economically use all the IP addresses present in the network? Okay. For example, take this 1.0.0.0. The range is 1.255. Do you see this range? Starts from 1.0.0.0 and ends at 1.255.255.255. There are so many addresses here, but we have only 10 devices in our network. How do we use only 10 IP addresses and not waste the other IP addresses present? That we will get to know using subnetting. You can also mention the types here. Class full subnetting. We have two types of subnetting. Class full subnetting, classless subnetting. What are these? We will see tomorrow. Okay. Noted. That's all for today, guys. Online guys, any doubts?
No, sir.
Okay, guys, then we are done for today. If you guys have no doubts, then we are good to end the class. No doubts?
No, sir.
Okay, guys, I'll see you guys tomorrow again. Bye bye. Take care.